In this video, I'm going to show you how to solve a different type of permutation and combination past year questions. Let's start with the first one. A 5-digit number is to be formed from 7 digits. So total digit, we have 7. N equals to 7. Each digit can only be used only once. Find the number of digit. 5-digit number can be formed if there are no restrictions. Whenever you are going to arrange a 5-digit number, is it a permutation or combination? It must be the permutations. Whenever it comes to arranging a code, a passcode, a password, NPR. With no restrictions, so total 7 number, and you are going to select 5 of them, 7P5. No restrictions. What do we have? 25, 2, 0. Okay. The second one, the number is divisible by 5. So we have 1, 2, 3, 4, 5. 5 slots, 5-digit number. In order to fulfill the criteria of being divisible by 5, which slot do we look at? The last one. The last digits determine whether it could be divisible by 5 or not. In order to be divisible by 5, the last digit has to be digit 5 or digit 0. Do we have that? We do. We will have digit 5. So we can put the digit 5 over here. Do we have digit 0? No. So you can only put digit 5 at the last slot. In that case, for the last slot, you only have 1 digit, which is digit 5. So 1 digit is digit 5, and you can only put it into the last slot. So 1P1. Okay? So we have 4 more slots to go. How many digits left? Think about it. Think about it. Total 7. Total 7 digits. 1 digit has been filled in at the last slot. How many digits left? 7 minus 1. So we have 6 more digits left. Out of these 6 digits, you are going to select 4 because there's only 4 slots. So 6P4. So the final answer is 6P4 times 1P1. 1P1 is just 1. So the answer is 360. Okay? Now you can pause the video whenever you need more time to think about. Okay, the C number is greater than 60,000. Think about it. In order to be greater than 60,000, which slot do we look at? The first slot, right? Okay, think about it. In order to be greater than 60,000, so which slots? Which digit do we slot in? 1, 2, 3, 5, 6, 8, 9. Definitely 9. What else? Or 8. Right? You can put 8 or 9. Can I put 6? If I put a 6 here, would it be greater than 60,000? Definitely, right? No matter what digit you put here, as long as it's not 0, 0, 0, 0. Couldn't be this case as well because you have no digit 0. It will be always greater than 60,000. So it's 6, 8, 9, right? So 1, 2, 3, 5, not possible. It's either 6 or 8 or 9. So for the first slot, how many options do you have? You have 3 digits, 6, 8, 9. So you have 3 digits, meaning you have 3 digits, and you're going to pick how many? Just 1, 3P1, because there's only 1 slot. So 3P1. And then for the rest of them, does it matter? No. So 7 minus 1, because 1 slot has been filled in. So you have 6 more left. And you're going to put in and place into 4 slots. So 6P4. 3P1 times 6P4. 1080. Okay. By the way, this is the 2017 paper. You will know which question is this based on the title here. Okay. Then the 4th questions. Let me clear this off first right now. Okay, the fourth question is the number is greater than 60,000 and even. Basically, we are combining two criteria, greater than 60,000 and even number. There are a few ways to look at this. There are a few ways to look at this. Do I have enough space? Okay, 1, 2, 3, probably. Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so it's either you look at greater than 60,000 as a first criteria, then the second criteria, or vice versa. Okay, it's up to you. So if I were you, I will look at this one, greater than 60,000. It could be 6 or 8 or 9, right? Just how we have solved this. So let's break it into 3 different cases. It could be starting from digit 6, digit 8, or digit 9, right? Only 3 cases. If you start from digit 6, in order for it to be even, what option do you have for even number? Look at this. 1, 2, 3, 5, 6, 6, 9. In order to be even, you can go for 2, you can go for 6, you can go for 8. Right? It's always recommended if you break into 3 different cases, so that even though they are overlapping of the usage of digits, then you will not confuse yourself. That's the best way. Okay, you lace it out very clearly. The case 1, this is case 1, start with 6. Case 2, start with 8, and case 3, start with 9. 3 different cases. This is the best way. Okay, the number is greater than 60,000 and even. Think about it. Think about it. If the first digit is 6, for the last slot, is it possible to put a digit 6 here? Is it possible? No, because one digit can be only used for once. So if you use a digit 6 here, you can't put in another 6 here. So you can only go for 2 or 8. That's the reason why I asked you to break into 2, 3 different cases. Okay, we go on quickly. So if the first digit is 8, then what can you put in the last digit? You can only put in 2 and 8. No, not 2 and 6, not 8 anymore, right? But if you go for digit 9 as the first digit, you can put all 2, 6, 8 at the last slot. So it's a different kind of case. Okay, now let me drag it in. I need more space for it. Okay, think about it. So this is 1P1, right? Okay, this is 2P1. This is 1P1. This is 2P1. This is 1P1. This is 3P1. Okay, how about this? All these are the same, right? Total, you have 7 digits. If you have fill up here, you only have 5 digits left for 3 slots. Therefore, 5 digits left for 3 slots is 5P3. It's the same for all 3 parts. And you find the answer for each case and then you add up together. For example, the first one, this one, right? You have 1P1, which is 1, 5P3 times 2P1, which is 2. So you have 1, 2, 0. And you do the same for the next one. I think it should be the same answer, right? Because it's the same kind of equations. So for this one, you have 1, 2, 0 as well. For the last one, 1P1 times 5P3 times 3P1, 180. So you have case 1, it could be start from 6, case 2 start from 8, or case 3 start from 9, 3 different cases. So it's the case of being either one of them. It's either this one or this one or this one. When it's all, you add up together. 120 plus 120 plus 180. Remember this, When it is all, you don't know whether it's case 1, case 2, or case 3. You add up all the possible ways. That will give you 420. Am I right? Okay. Next one, the same paper, part B. Ranjit have 25 friends, 15 are boys, 10 are girls. Select 7 friends for a birthday party. Number of different ways from selecting 7 friends. NPR or NCR? NCR, no arrangement, order does not matter. So NCR. So total 25, and you need to select 7 people. No restriction, 25C7. Nothing to discuss. Okay. Only 2 out of the 7 friends are boys. So basically it means they want 2 boys. And how many girls? Total 7 people. So 2 boys, 5 girls. That's the meaning of it. Okay, 2 boys, 5 girls. So 2 boys, it has to be 2 boys. So if it has to be 2 boys, you have to select from the group of boys, 15 of them. So 15C2, and whenever it comes to n, you multiply. And how many girls do we have? 10 girls. So out of these 10 girls, we need 5 more. So 10C5. 26460. Okay, good. You see, when you add up here, it's always a total number of friends, 25. When you add up here, it's always 7, which is the total selected number of people. It's always this case. You can check your answer. Next one, 25 friends include a boy and his sister who cannot be separated. What does it mean? A boy and his sister is a sibling. This sibling cannot be separated, meaning if the boy is selected, the girl will be selected. If the boy is not selected, then the girl will not be selected as well. Am I right? Cannot be separated. So they are always together. So there's 2 different cases. Case 1. Case 2. Case 1 is both of them are selected. Okay? Case 2, both of them are not selected. If both of them has to be selected, then in order to make sure that they will be selected, they ought to be selected, then you have to choose from 2 of them, right? Has to be selected. So 2C2, they must be included, okay? And if 2 of them must be selected, then how many other friends do we have? 25, you minus 2, so we have 23 friends left. And out of this 23, how many do you need? You need 7 in total. We have selected 2, so you need another 5 here. Check again. Is it 25? When you add up, yes. Is it 7? Yes. Okay. Answer. 2C2 is just 1, so you can just ignore it. 33649. Good. Case 2, most of them are not selected, meaning to say 2 of them, you have to exclude them. None of them will be selected. 2C0. None of them will be selected. And how many left? 23 left, and we need 7 more. Am I right? 2C0 meaning to say 2 of them are not selected at all. So when you add up, still 25, still 7. 2, 4, 5, 1, 5, 7. Okay. Add up. Case 1. Add up case 2. Final answer. 278806. Okay. Next one. A 6-digit number is to be formed using digit 1, 3, 5, 6, 8, 9. 1, 2, 3, 4, 5, 6. Oh, okay. Oh, no, this is not needed. The same kind of question, right? We skip. We only look at this one. Luby wants to have a party with her friends. She invite 8 of her friends. No restriction. So out of 15, you need 8. I don't think I need to discuss it. It's 15C8. Okay? You figure the answer. What we're going to discuss is this one. 2 of her friends are twins that cannot be separated. Oh, it's the same thing, right? It's the same question as just now. Either case 1, both of them are selected, case 2, both of them are not selected. They cannot be separated. So same kind of questions, we skip. Okay, this one. 8 books are to be arranged on a shelf, 4 mathematics books, 3 geography books, and 1 French book. No restrictions. Total how many books? Total 8 books. Out of these total 8 books, you are going to arrange. Arrange, the keyword is arrange. So P. Are you going to arrange all of them into all the shelves? Yes, so 8P8, no restriction. 8 factorial, okay? Then that will be the answer. Okay, what I want to discuss is this one. The math book has to be kept together. This is what I want to discuss, okay? The 4 math book, and it has to be kept together. So when you have situation like this, you need to visualize it as if you are going to tie all 4 math books together. Tie it together, okay? Just imagine something like this. 3 geography, 1 French book. Okay, so we have 3, 1 more, 1, 2, 3, maybe geography book, and then here is the French book. Am I right? But for mathematics books, very special. These 4 math book, we are going to tie it together to make sure that they are always placed together. So you have to imagine as if you are tying it together. I will tie all the math book together because it has to be kept together. So when you do that, it's basically a one entity. One entity consists of 4 math books to be together. One entity. So think about that, right? 4 math book here. Okay, the rest is for geography, geography, and also geography, and also French book. But this is not the only arrangement. Am I right? You can actually place any of the 4 math book in between here, meaning it could be in between here or here or here or here. Am I right? You can place the 4 math book at the top left, and after that, it could be in between here, it could be in between here, it could be in between here, or it could be the last slot. Am I right? It could be anywhere. So think about it. If it can be arranged in anyhow, first, second, third, fourth, and fifth slot, this 5 entity, 1, 2, 3, 4, 5, this 5 entity can be swapped anyhow they want. If they can be swapped, basically this is what? 5 entity. This is 5p, 5. Am I right? This is 5p, 5. Okay. So 5 slot, 5 entity, 5p, 5. But do remember, among the 4 books here, they can swap among themselves as well. Am I right? So whatever happened inside between the 4 math book, they can swap among themselves. That will be 4 book, and you arrange 4 slots. So that will be 4p4. So among the book itself, it is 4p4. So the idea is, if you look at the entity, we have 1 entity, maybe for French book, 3 for geography. This one for French, this one for geography, this one for geography, this one for geography. The last slot is for the math book, 4 math book. This 5 slot can be interchanged. That's why it's 5p5. But among the 4 math book being tied together, they can swap among themselves. So this is 4p4. So the answer is 5p5 multiplied by 4p4. What do we have? 2880. Okay. Okay, same thing. Okay, this is a bit special. A team of 6 players is to be chosen from 8 men and 4 women, total 12. You're going to select 6 to 12C6. No restrictions, 12C6. Okay, you figure out. Okay, I want to talk about this. There's at least 1 woman in the team. 12C6. 8 men, 4 women. At least 1 woman. Think about it. At least 1 woman. This is for woman. This is for man. At least 1 woman. Is it meaning for the woman there's just 1 woman? 1 woman. If it's 1 woman, meaning there should be 5 men, because total must be 6. So at least 1. Does it mean 1, 5? No, right? At least 1 meaning it can be 1 woman, or 2 women, or 3 women, or 4 women. Could it be 5? No, not possible. Maximum we have only 4. So no, not 5. 1, 2, 3, 4. So if it's 1 women, then it's 5 men. So if it's 2 women, that will be 4, 3, 2, am I right? So total will be 6 anyway. So there are 4 cases, am I right? So if I can do it this way, then of course I can do it this way. But it will be long, the working step. In order to be 1 women, so I have 4C1, total 4, 4C2, 4C3, and 4C4. And then for the man, XC5, XC4, XC3, XC2. You can list out like that, okay? You can do it like that. You can have 4C1 multiplied by XC5, case number 1. You got the answer here. And you do that, you got the answer here, and you do that answer number 3, and you do that answer number 4. Because we do not know which is the case, at least one. It could be number 1 case, number 2, or number 4 case, case 1, 2, 3, 4. So this 4 answer, you add up together because you don't know which one is the case. It's a OR. O-R-O, right? It's not N. It's not A-N-D-N. It's O-R-O. This is the long methods. Is there any shortcut? Yes, there is shortcuts. There's only 2 marks for this. The idea is, if you want to find the answer for this, you can have the idea of no restrictions minus the opposite case. What does it mean by opposite case? The criteria that the son does not fulfill at least 1 man in the team, the opposite case. Think about it. What is the opposite case of not having at least 1 woman in the team? Not having at least 1 woman in the team. I'm not talking about impossible case. I'm talking the opposite case. Because the impossible case will be 5 women. Not possible, right? So not this one. Something that is possible, it's just that it does not fall into this criteria as this 1 woman. What is the case? Think about it. At least 1. So the opposite case is 0 woman. Am I right? Right, that's the idea. But is it possible to happen? Yes. It could be 0 woman and 6 men. It's just the opposite case. So if that's the case, no restrictions, there'll be 12C6 minus the opposite case. How many for women? 0. So 4C0. And how many for men? 8C6 for men. And that will be the shortcut for these questions, okay? So you have 8, 9, 6. All right, so let's go to the next one. Okay, this one. 9 different books, 4 math, 3 physics, 2 chemistry. Okay, no restrictions. We are not going to do about it. A chemistry book is at each end of the shelf. So you have 9 books and 9 slots. 1, 2, 3, 4, 5, 6, 7, 8, 9. Am I right? 9 slots. Criteria, chemistry book at each end of itself. How many chemistry books? 2. So you must put a chemistry book here and chemistry book here. At end of, okay, that's it. Am I right? So think about it. You put 1. Okay, think about it. First, this one, how many options do you have? This one, if you have 2 chemistry books, right? So you have 2P1. So after you fill in this slot, you have only 1 option. You have another 1P1 here. Am I right? Some of you like to do like there's only 1P1 here and then 1P1 here. If you write 1P1 here, make sure you times 2 at the end because these 2 chemistry books can interswap. Am I right? But if you think about this, you fill up the first slot first. There's 2 chemistry books for the first slot, 2P1. Then for the last slot is 1P1. Then you don't have the times 2 in the end because you have to do it now, right? 2 options here and 1 option here. Okay, 2P1, 1P1. How many books left? 7 left. 7 slot. 7P7. Multiply it together. 10080. Okay. Next. Okay, just look at the last one. 6 children to be selected out of 18 boys and girls. More boys than girls in the team. Think about it. Okay, category, boy category, girl category. More boy than girls. Okay, maximum number of boys, 8, but you need only 6. So it could be 6 boys and how many girls? 6 boys and 0 girls. Or it could be 5 boys, 1 girl. Total must be 6. 4 boys, 2 girls. 3 boys, 3 girls. Does it make sense? No. Then it will not be boys more than girls. If I go on, it will be 2, 3. No. 1, 4. 1, 5. No. And then 6, 0. 0, 6. No. So you have only 3 different cases. Am I right? So what you can do right now is to continue to write this. If it's 6, if you're going to select 6 points, that will be 6C, 8 of them. 8C6, and then 10C0, 8C5, 10C1, 8C4, 10C2. This one multiply with this one multiply by this one multiply by this one. And then you got to answer 1, 2, 3. You add up together. That will be the total case. All right. We move on. Okay, let's talk about this. All right, this one you have to be very familiar with the NCR formula. Remember this NCR formula? When you have NCR formula, it will be the same as n factorial, n minus r factorial, r factorial. So we are doing this, okay? N items taken 3, so NC3 equals to 6 times the number of competitions equals to 6 times NC2. That's the equation, okay? And you find n. Okay, let's change it. NC3, change it to this n factorial. This one, you put it here, all right? And then n, you put it here. This is your n, this is your r. So you put a 3 here, you put a 3 here. So you have n minus 3 factorial, 3 factorial equals to 6 oh, not enough space, huh? Okay, never mind. So I have n factorial over n minus 2 factorial and then 2 factorial. Okay, so I'm gonna lop this off. I'm gonna bring everything over to this side. Okay, I want to give you an idea first. That's an idea where I need to recap you first. 5 factorial equals to 5 times 4 times 3 times 2 times 1. Am I right? Okay, then 4 factorial is the same as 4 times 3 times 2 times 1. Think about it. Wouldn't this part is the same? So basically, I can change 5 factorial to 5 times. I can change this part into 4 factorial. Am I right? If I don't want to, I can also change it to 5 times 4 times 3 factorial. So the idea is, whenever I start with 12 factorial, I can change it to 12 times 11, like I minus 1, okay? And I minus 1, it'll be 10, and I minus 1, it'll be 9. If I want it to stop, I can just put a factorial. That's how I can change it. So if it's unknown, think about it. If it's n factorial, I can change it to n, and then I minus 1. That will be n minus 1. And then I minus 1, that will be n minus 2. And then I minus 1, that will be n minus 3. If I want to put a stop, I put a factorial here. That's the idea. So now what I'm trying to share with you is that these two part n minus 3 and n minus 2 factorial, one of them, you can change either one of them. So I'm changing n minus 2 factorial. That's a reason why. Okay. I'm changing it to n minus 2, and then I minus 1. That will be n minus 3. I can go on and I can write n minus 4 here, but it's not going to help, because if you have a look on the left-hand side, it is n minus 3 factorial. So it will be good if you just stop at n minus 3, and then you put a factorial. Why? Okay, why? Because you can cut it off later on. You can cancel, you can simplify it. Okay, let's see here. It's always about simplifying though. Okay, 3 factorial, we have 6. 2 factorial, you have 4. Okay, and then 6 you put on top, n factorial. Now we can cancel off the same thing on the same level, meaning this one and this one can cancel off. Am I right? Because they're on the same level, equal. So I can cancel off it, n factorial, n factorial. N minus 3 factorial and n minus 3 factorial can be cancelled off. So we have 6 here, then it will become 3. We have 4 here, become 2. And then 6 divided by 2, it will be 3. So what do you have now? Okay, so what do you have now is you have 1 over 3 equals to 3 over n minus 2. Just a linear equation, am I right? So n minus 2 equals to 9, n equals to 11. That now let's check it out, okay? Let's check it out. If the answer n is 11, is it correct? 11C3 is the same as 6 times 11C2. Let's check it out. 11C3 is 165. Okay, something is wrong. Let me check. The answer is not right. NC3, n minus 3 factorial, 3 factorial. 3 factorial is, 2 factorial is 2. Something wrong here. It's not 4. This is 2. Okay. If this is 2, then the moment it cancels off, it's cancelled off already. Then this should be a 6 here. 6, 8, 19, 6, 18. That should be 18. Then n should be 20. Okay, that's a mistake. I'm so sorry about it. Okay, that's a mistake just now. Because 2 factorial is just 2, not 4. Okay, now we check the answer here. Okay, this one 20, this one 20. 20C3, is it the same as 20C3, 1140? Okay, correct. Okay, that is the answer for the case. Okay, right? So we go on as the last type of questions. Find the number of ways that 12 people can be good in the 3 groups, 3, 4, 5. This is like that. Is it NPR or NCR? NCR, right? Just putting groups, no order. So 12 people, 3 groups. So you can start with 12 person. Do you want it to break into the groups with 3 people, 4 people, or 5 people first? Up to you. If you start with 3 people, that will be 12C3. Am I right? Select 3% in a group. And then, so it's multiplied. Once you have select 3%, how many people left? You have only 9 people left, because 12 minus 3. And out of these 9 people, now how many you can select? So you're going to select 4 people. So you have 9C4. And after that, 9 minus 4, you have 5 people left. Basically, you have no choice at all. So it's 5C5. And that will be the answer. Okay? But some of you argue, why do we have to select the 3 people group first? Or it's the same, no matter how you think about it. Okay? If you want to do a different way, okay, 12 people, you don't want to start with 3% group, then you can have 12C4, then you have 8 people left, and then you go for 3 people groups, then you have 5 people left, 5C5, you still get the same answer. Okay? That's all. Thank you.